Abbott has come out with quite a bit of exciting testing. Actually, they're just one company, but they're probably the most famous because President Trump had one of their devices saying it's going to give you a result in 10-15 minutes. And that is correct. It could get a result in about 15 minutes or less. So today we'll go over the two types of testing that are rapidly becoming available. The test for the virus itself, and then the antibody testing. So one important thing to note is that there's a lot of information available, especially on their own website. Sometimes you have to click on where it says HCP, Healthcare Professional. So let's start first with the rapid test that detects the viral DNA. They call it ID NOW. So I put a link at the bottom to the FDA website. They actually have some more information there, and so we'll go over the information they have listed there first. So first, it's important to know that their test detects viral DNA. So the virus, as we said before, the coronavirus is an RNA virus. You could be DNA or RNA virus, but they're an RNA virus. It's a qualitative test. It's important to realize this because we always prefer quantitative tests. Qualitative tests are just a yes or no answer. They also have an indeterminate there sometimes, but the idea is that they put in an arbitrary cutoff that we don't know because they didn't tell us. As doctors, many times we prefer to know because then we can make a judgment call. So for example, pregnancy tests, they're mostly qualitative. You are pregnant or you're not, but many times it's not quite so simple because it might be very low, but you could be pregnant. Well, it depends on how much you know, right? The test doesn't know enough, but say this person thinks they are pregnant and spend a few weeks and you look at the level, you're like, oh, well, sorry, you're not. Because the level is just too low for being so many weeks. So it gives you the ability to make further judgment calls if you have a number there. But qualitative is sort of what these tests are because we don't have a lot of data on this yet. They use a method that's also similar to PCR. Basically, it is PCR, polymerase chain reaction, but they're just making more of the RNA so they could test for it. And so the way they sample it, you could have nasal, nasopharyngeal, and throat swab. So nasal is just in your nostril. Nasopharyngeal has to go all the way back and poke into your throat, and then a throat swab. The irony is that their study actually, when they're validating this, used a nasopharyngeal swab, which is what I was told was the proper way of doing it. So I don't know why they say you could use these other methods if they did other testing to do that. They have listed their limits of detection. So it's 125 genome equivalents per milliliter. But they didn't actually test this limit of detection. They tested 2 times this detection. So if it's 2 times this level, they're pretty sure they could get it. Where did they get their data? So this is the issue. The virus doesn't always look the same. We talked about different strains before. And so the virus can be different, and there's different variations of virus. HIV, for example, is a very well-known virus for mutating. And so they looked at all the publicly available nucleic acid sequences in NCBI and GenBank. And they said it was okay as of March 2020. So that's sort of about a month ago now. Things may be changing, there may be no information. The limits with using detection of a virus, right? The sort of genetic material, the nucleic acid sequences, is that if it changes, you may miss it. And so there's actually a test that came out that a lot of people ask about. It's a stool test that's supposed to be better than just the standard fecal blood test for cancer. They're actually testing cancer sequences. And so a lot of GI doctors, of course, who have a bias because they don't make money from doing that test. They make money from doing colonoscopies. But they say it's not effective because you can't actually see it. So if you see a cancer, you don't really care what genetic material it has. You see it's a cancer. However, if you just test genetic material, there may be a new cancer and you can't figure it out because it's a new cancer. Whereas if you visually see it on a colonoscopy, you can still guess it's a cancer. So that is one limitation. But they also made sure to test against other viruses and bacteria that are very common in lung to make sure that they don't react and cause it to be positive as well. And so they tested other coronaviruses, common cold viruses, bacteria that are well known to cause pneumonia. And so this is sort of their test. And if you look at their tests, right, the question is, how good is this? So if you were to compare the results of this test versus traditional testing, say in a CDC lab, how well does it correlate? And I can't actually tell you the answer to that. I can't seem to find that information available. It's actually funny, I got all this information from the FDA website, I think when they're getting Abbott approval, but Abbott's own website doesn't contain this information, even in quote to healthcare professional data sheet. So let's move on to rapid antibody testing. So you have to get a pinprick. The sample is going to be blood because that's where we find our antibodies. And so how do you know these tests are effective? What antibody are they testing for? I don't know the answer to that. All I could tell you is that they're saying it correlates to the PCR, as in this person had it, they tested positive on the PCR for coronavirus. And so do they have these antibodies, and what time period? Because as we know, they develop later in time. So the first one to come out would be the IgM, which comes and goes, and then the IgG will come slower, but it's sort of the memory one. It will remain until later. And so again, it's a qualitative test. They're not telling you the quantity. You can't figure out somebody's quote immunity, as in how immune they are compared to somebody else, because you don't know how much of the antibody they have. And then in terms of the specificity and sensitivity, well, Abbott listed 99.57 for specificity and 86.43% for sensitivity. If you look at another company that's made it, Biomedomics, theirs is 88.66 for sensitivity and 90.63 for specificity. So much more similar. Remember we said specificity and sensitivity is a cutoff number, right? Many times one goes up, the other goes down. Specificity is for ruling in, spin. Sensitivity is for ruling out. So this antibody test is good. The Abbott one particularly is almost 100% specific, meaning if it's positive, they'd have the antibody. They've had it. If it's negative, well, not really sure what to say. The Biomedomics one is sort of, more well-rounded, but I would say, depending on what the purpose of the test is, I think right now the test is sort of saying whether you had it or not. And so I think the Abbott test having higher specificity is pretty good. So this is a little bit of information about the Abbott tests. And I think these are the tests you're going to see popping up more and more. And this is how to understand these tests. And I have a link at the bottom about the Abbott ID NOW, from the website of the FDA, talking about the actual specifics of how they do it.